in this lecture I will discuss renewable energy status in India. So what we have in India, we have Ministry of New and Renewable Energies, MNRE, that is Ministry of New and Renewable Energy. Now they are promoting newer renewable electricity, and the sources are targeted to grow massively by 2020. This is the recent target. By 2020 it is planned to have so many plants that the capacity becomes doubled, including a more than doubling of India's large wind power capacity, and almost 15-fold increase in solar power from April. I would say, I would put it here, all double wind power capacity and 15-fold increase in solar power by this year. So this ministry was also working with Ministry of Power who have recently announced that in 10 years we would not have any coal that would be used to generate electricity. That is, by 2027 they are planning to eliminate the use of coal to produce electricity, that is thermal power plant are getting closed. So these grand targets, these are the grand targets to close the coal power plant, to have 15-fold increase, double the wind power capacity. So have placed in India amongst the world leaders that are promoting renewable energy. So in India, it is world's largest renewable energy expansion program, that is 175 gigawatt till year 2022, which is more than 4 times of the energy that was target of that was 43 gigawatts in April 2016, more than 4 times of energy, that is 43 gigawatts in April 2016. If I break down this 175 gigawatts, it includes 100 gigawatts of solar power, 60 gigawatts of wind power, 10 gigawatts of biopower, and remaining 5 gigawatts from small hydropower plants. So from these resources, this is the plan. So things are moving very rapidly in India as well. The solar capacity increased 370% in last 3 years. This is also a report that was generated in April 2016. So from around 2.6 gigawatts to more than 12.2 gigawatts. Also there is a push for solar energy in India. India has moved up to a second spot, like second position in world. It was third. From third it has moved to second position in renewable energy country attractiveness index. Energy country attractiveness index. In this index, India has moved up. This is primarily due to combination of strong government support and attractive economics as well. So, for the people who are working in renewable energy sector or who are working in green technology sector, this is a great boon. We have a great future ahead. In recent years, the development is being held and we are the part of it. So, we are working in green technologies. This is renewable energy only. Also in green technologies, government is supporting, subsidies being given for green technologies, for green products as well. So, what we see here that India is very important part of International Solar Alliance. International Solar Alliance. So, this what does this International Solar Alliance do? They promote the development of solar power in more than 120 countries across globe. Across the globe. So, this is our status here. So, this is grid connected renewable electricity. Now, installed grid interactive renewable power capacity is given here, that exclude hydropower, because hydropower was all existing in India from way back, from many years. So, in wind power the total installed capacity is 32,000 megawatts, and 2023 it is targeted to take it to 60,000 megawatts. So, it is a kind of a double. In solar power we are moving it to 15 times. So, it is only 12,000 here, we are taking it to 1 lakh. So, in solar power also it is increasing multiple folds here. So, from 12,000 to 1 lakh in 2022. In biomass power, biomass and gasification and bagasse cogeneration. So, this is waste to power. So, these two combined would be extended to 10,000 megawatts. So, these are the targets. Small hydropowers also is there is little increase in this one. So, this would actually part of 60 megawatt, 100 megawatt, 10 megawatt, 5 megawatt would be part of the total 175 megawatt of energy. So, this is actually gigawatt. 175,000 becomes 175 gigawatts. So, the target is given for biopower as well, which includes the biomass power and waste to power generation here. So, this is the status here. Now, next I like to move to industrial symbiosis. So, what is industrial symbiosis? What is industrial symbiosis? Benefits of industrial symbiosis, these are the questions. So, what kinds of companies can have symbiosis between them? These are the question. industrial symbiosis is essentially an association between two companies who are kind of dissimilar companies, in which byproduct of one company becomes the raw material of other company. For instance, the materials like tire sheds, chips, fly ash, and plastic pellets, all those are a kind of waste material for one company. For the other company, these can be raw materials. So if these two company bring their hands together and make an association to use each other's, to use these products for the benefit of both, that is called as industrial symbiosis. So what happens in industrial symbiosis? The benefits here are reduce the raw material and waste disposal, reduce raw material because the material is obtained from the other company, and reduce waste disposal, earn new revenue here. Then also we can divert the waste, divert from landfill and reduce carbon emissions in that case. So this also open ups, yes, also this also opens up new business opportunities. For the recyclers, for the trading companies, and similar other parties here. So actually this type of industrial synergy, this is kind of energy industrial synergy. So this is industrial synergy. This kind of industrial synergy bring advantages to both the parties here, and usually done for both commercial and environmental benefits. Commercial and environmental benefits. So what happens in industrial symbiosis is, for example, I have one company, factory A, and it has some bioproduct. Maybe it water is being splashed out. For example, if water is being thrown out by this company, this can be used by some factory B who has water as its input. And also this energy, for example, this factory would need heat. C, which has heat as its output, that can be used by this company. This is heat, water, and maybe if I put some more company here, factory D. So it can also have, for example, this factory is having water. This water could also go here as well if it is required. So we can have any these kinds of connections in which the byproducts, these all water, please note these are byproducts only. In industrial symbiosis only byproducts are being considered. So these are working with each other, and in turn helping each other and having commercial and environmental benefits. So industrial symbiosis is not only reducing waste and promoting energy efficiency, it is way beyond that. So waste from one company can be redirected and is used as raw material for other company. Fuels used to generate electricity can provide local heating here. Less industrial waste needs to be disposed in this case. So cooperation improves the performance of the companies involved, and this contributes to building a strong local economy. So this will also help to maintain job opportunities in this local range. So not only local economy, even the distant companies can share their hands. So here distance is not a barrier. So the companies may be close together or far apart, producing the same things or completely different ones, and the resources they share may consist of materials, energy, or maybe water. And it is used to be thought that industrial symbiosis work effectively if the companies are close, but distance does not matter here. This is no longer the case, though it is not a good practice to use transportation or the transport the material to far away companies, but in certain cases it is beneficial to use the recycled or the byproduct materials than to use new materials, and the transportation emissions are also compensated in this one. So in this case distance is not a barrier, so always we can evaluate that what is benefit. Do we uh, buy new material or get byproduct plus transportation cost and energy? So these two again can be evaluated, which option to be done, one or two. So what all synergies here have in common is that they reduce cost, generate new sales for the companies involved, as well as they create significant environment benefits such as reduced landfill, as reduced greenhouse gases. So here is an example of industrial symbiosis which is there in river Mersey banks, that is going towards a sustainable future. This is taken from a reference here. This is in UK. So there is a coal fired power plant here which has fly ash as its byproduct. So we know that cement also has fly ash as some of this constituent, 5 to 10%, maybe 5 to 20% of the cement fly ash cement it is involved. So this can be used here. So this is actually the real industrial symbiosis that is happening here in UK along the banks of river Mersey. So in this case gypsum is also used in wallboard plant here. So also here waste goes to this greenhouse, to fish farms, heat goes to our district heating system to provide heat in the houses, and this coal fired power plant is also getting the flared gases, waste water from this company here, and steam is also getting here. So this is a two-way process going on, one way in another way out. Wastewater is getting in, steam is going out here. So this steam can also be is also used here by a pharmaceutical plant here, and this is also giving its output to the sulfuric acid manufacturer. Pharmaceutical plant is further giving its outputs to this fermentation sludge is being given to the agricultural land here. The surplus yeast is also provided to increase the yield here. So this is a kind of industrial symbiosis here. So a beautiful industrial symbiosis example is in Denmark. So this is a kind of a symbiosis that acted as a model. So this was not essentially created as a symbiosis, but for only business benefits. It was started in 1959. So what is this? This is Kalundborg symbiosis. So in Kalundborg symbiosis, the industrial park was not originally planned for this industrial symbiosis, but in 20 years it developed as this type. So in the present state we have Arnes power station that is getting fresh water, cooling waste utility from Lake Tissot is getting fresh water. Then from this refinery it is having cooling waste, fuel gases are also from this refinery, and waste heat is going out here, and for district heating also it is used. The scrubber sludge is there going to our Gaiproc wallboard plant. Waste heat is again going to fish farms as well. Fly ash is going to the cement factory here, and this pharmaceutical plant is also getting steam from this one, and this treated sludge is also going to neighboring farms. So this was the model industrial symbiosis in Denmark, Kalundborg. So this was the first full realization of industrial symbiosis. First full realization of industrial symbiosis. So in this 3 million cubic meters of water is saved and reused. 3 million meter cube of water is reused and is saved through recycling as well. And 150,000 tons of yeast. This replaces 70% of soy protein in traditional feed mix of more than 80,000 pigs here. So 70% of soy protein. So see the benefits here. These are only a few examples here, and certain other benefits of similar kind are obtained from this industrial symbiosis. This was just a block diagram kind of view of industrial symbiosis. So I have also a location view. This is also taken from a reference here, but this is the same power plant. So this is actually drawn to scale here. So this all in this red color we have steam. The steam is going here, and in this blue color we have water. In green color we have gases going here. In yellow color we have gypsum. In red color again the steam is here. So we can see that this is a beautiful example. You can go to this reference and read more about this industrial symbiosis. So I would recommend here to read this study that was carried out in Yale University, US, about an industrial symbiosis study in India. So this is regarding the industrial symbiosis study in India. So this is regarding the industrial symbiosis study in India. So this is regarding the industrial symbiosis study in India. So this is regarding the industrial symbiosis study in India. So this is regarding the industrial symbiosis study in India. So this is regarding the industrial symbiosis study in India. So this is regarding the industrial symbiosis study in India. So this is regarding the industrial symbiosis study in India. So this is regarding the industrial symbiosis study in India. So this is regarding the industrial symbiosis study in India. So this is regarding the industrial symbiosis study in India. So this is regarding the industrial symbiosis study in India. So this is regarding the industrial symbiosis study in India. So this is regarding the industrial symbiosis study in India. So this is regarding the industrial symbiosis study in India. So this is regarding the industrial symbiosis study in India. So this is regarding the industrial symbiosis study in India. So this is regarding the industrial symbiosis study in India. So this is regarding town Nanjangud, which is there in Mysore district of state Karnataka. India. So this is also a very good example of industrial symbiosis in India. So specifically the name of the study is industrial symbiosis and residual recovery in the Nanjangud industrial area. So you can go through this and see the beauty of industrial symbiosis. So with this I would like to stop here, and I would come with my lab demonstration and other sessions in the coming lecture. Thank you.